Okay, now third exercise. Third exercise. Third. We have a gas at temperature or pressure 2 atm. Initial gas 2 atm. Okay, I will not read it. Just we have some gas. Initial temp. It's a first position. Then it is a thermally expands. When it expands isothermally, his volume is doubled. Is doubled. Is a second position. Then it goes back to his initial volume, third position, and we shall find. What should we find? We shall find its original one. The first shows the process of PV diagram, then find the final temperature and pressure. Okay, P1 is, we know the P1, so also we know the initial temperature T1 is 200 Celsius. Also what we know that the volume will expand, will be doubled in isothermal process. For example, if it's V1, there will be 2V1. It means it will be doubled. And here is our graphic PV. This is our graphic PV diagram. P and V. Here is V1, here is 2V1, here is some P, let's say 3 unknown, and here is P1. Here P1. So we draw a graphic, then we should find this P3, what P3 and T3. What's them? Okay, to find it, we should first find what can we do? We can write the ideal gas formula, yes, PV under T, this formula, to first and third points as situations. First is a P1 V1 equals to nRT1, nRT1. nRT1, and third is P3 V1, yes, because here's the volume is also V1 equals to nRT3, yes. Not third. I'm sorry. We should here write this is second. Actually, second is P2 in P2 in second position. His pressure is P3 actually, but volume is 2V1. Yes, here 2V1 and nR. Why we use second? Because we know its temperature is also T1. Yes, because it goes isothermally. In isothermal process, temperature remains constant. So we will divide these both formulas. nRT and nRT will be cancelled. V1 will be also cancelled. Here we can see that P1 equals to 2P3, where is P3 equals to P1 over 2, and P1 since 2 atm, P3 will be 1 atm. We found P3. So let's find the final temperature. Also, we should write. What should we write? Let's write the pressure in first and the final. The formula for the first and the final is P1 V1 equals to nRT1, and the third position is P3 V1. Yes, they have equal volume, and nRT3, which we should find. Here, if we will divide V1 will be cancelled, nR will be cancelled, and T3 equals to P3 T1 over P1. And if we will calculate it, P3 is 1. There is T is 200 Celsius, but we should convert to Kelvin. It's not 5. It is 473 Kelvin, and divided by P1 is 2 atm. You will get that T3 equals to 236.5 kelvins. Or if you will convert to Celsius, it will be minus 36.5 Celsius. That's our answers.